This video is for The Living Earth, Unit 2.6, Erosion and Deposition. Today's essential question: how do rock and soil undergo erosion and deposition? First main idea: the relationship between erosion and weathering. Erosion is the overall process that results in the movement of rocks and soil from one place on Earth's surface to another. Erosion is facilitated by a series of processes, including chemical and mechanical weathering. These things wear down rocks and minerals at Earth's surface. When rock has been weathered into smaller pieces, it is then transported by forces such as wind, flowing water, and gravity. These processes modify the surface features of Earth, leveling and removing many landforms. Weathering is a prerequisite for erosion. Mechanical weathering occurs when rock is broken down into smaller pieces by physical means. This process does not alter the chemical nature of the minerals in the rock. Chemical weathering is the process of breaking a rock into smaller particles by altering the chemical structure of the minerals in the rock. Exposure to water is a common cause of chemical weathering. Chemical weathering processes can weaken a rock, making it easier for mechanical processes to break the rock into even smaller pieces. Our next main idea: erosion and deposition of sediment. Chemical and mechanical weathering processes break down rock into smaller particles. These particles are called detritus. These smaller particles are loosened and then removed from their original site. This process is called erosion. The agents of erosion include water, wind, ice, and gravity, and occasionally lava flows. Organisms can also act as agents of erosion and deposition. For example, marine invertebrates may take up sediment during feeding in one area and expel it into another. However, these effects are typically so small compared to those of non-living agents that organisms are not commonly considered to be important agents of erosion and deposition. The rock particles are carried by erosion and are called sediments. When sediments accumulate in new areas, the process is called deposition. Deposition occurs when the speed of the medium transporting the sediment diminishes, allowing the sediment to lose speed, fall, and eventually come to rest. Over time, sediments accumulate in low-lying regions called sedimentary basins. A sedimentary basin is a low area in Earth's crust. It does not have to be shaped like a basin or a bowl. Sometimes a sedimentary basin is just a gently sloping surface. In this low area, sediments accumulate, and some sedimentary basins can be as small as a few hundred meters, while others can be as large as an ocean. Deposition always follows erosion. Most sediments originate on land. Some are deposited into rivers and lakes and ultimately end up in the ocean. These sediments may accumulate on the ocean floor, near tectonic plate boundaries where ocean and continent meet. Along these boundaries, the accumulating sediments are forced upward as the ocean crust is subducted beneath them. This creates a wedge of uplifted, accreted material, and over long periods of tectonic convergence, these sediments can be uplifted to extreme elevations and incorporated into mountain belts. Such examples of uplifted sediment can be observed at extreme elevations in places such as the Andes Mountains in South America, the Alps in Europe, and the Himalayas in Asia. Where a sedimentary basin is trapped between colliding continents, the sediments are also compressed and uplifted to form mountains. For example, where the Indian subcontinent meets Asia, the sediments trapped along their edges have been uplifted to form the Himalayas. This is why fossils from sea animals are found on the peaks of some of Earth's highest mountains. If we look at most mountain chains around Earth, we can trace their origins to current or ancient plate collisions. Sedimentary basins also form in low areas on continental plates when the tectonic plates are stretched by extensional forces. Where tectonic plates are stretched, these basins can then form. These fill with sediments that may be compressed and folded to form mountains by later plate activity.
Rivers are streams of water that travel downhill. They carry water to lakes or to oceans. The tiniest rivers are creeks or streams. They may be small enough for you to jump across. The biggest rivers may be several miles or kilometers wide. A river may carry water across your town. Longer rivers carry water across a state, and the longest rivers carry water across a whole country. In this map of the United States, you see just some of the rivers that flow through the country. Look even closer at Kansas to see in how many places we find rivers and streams. Rivers and streams can have deep water. It may move fast enough to carry pieces of soil called sediment, along with large rocks. Over time, moving water can wear down rocks and dig deep into the ground. That's called erosion. Even slow rivers can erode rocks and carry sand, soil, and even pollution. Water is heavy, and it's strong enough to hold up a boat. Look at this demonstration. It's a container of water with two holes on opposite sides. We see that water has power to make things move. Moving water has so much power that it can turn water wheels, called turbines, to make electricity. That's called hydroelectric power. A man or woman who studies moving water is a hydrologist.
At this point, you should be able to generate a full and appropriate response to today's essential question. How do rock and soil undergo erosion and deposition?